Okay, good morning students. Today in chemistry we discuss about osmosis and osmotic pressure. Previously we have discussed about molar elevation constant, molar depression constant, relative decrease in vapor pressure, and from that we try to find the molecular mass of solute added in the solution. Today we discuss the fourth topic, that is osmosis and osmotic pressure. First we discuss about osmosis. Osmosis. Okay, osmosis is a natural process. Suppose we put fruit in water, then water will enter into the fruit. You take some fruit and try to eat it, then first it goes to your stomach, and from stomach it goes to your animal cell, means your cell. So this process of migration of solute and solvent, that will come in the osmosis. Which component will migrate, that we will see. For that we prepared one chamber. In one we have solvent, and in another chamber we have solution. This solution I have added NaCl. Okay, suppose it is 1 molar. In this chamber I have prepared the solution, and that is 1 molar. This is solution number 1. Here I have prepared the solution number 2. That is NaCl only, but here it is 5 molar. In this I put the semi-permeable membrane. Between all three chambers there is semi-permeable membrane. Semi-permeable membrane, SPM. This semi-permeable membrane allow only solvent molecule to migrate. Just like animal cell, the pore size is very small. So here semi-permeable membrane 1 nanometer is given. Its pore size number is given 0.504. So only solvent molecules can migrate. Solute molecules cannot migrate. Semi-permeable membrane. The numbers are given 5, 6, 7. So different semi-permeable membranes are there. First we discuss this. Here if you fill solvent, means water, it is nothing but it is H2, and here you put solution, that is 1 mole, and here you put the pressure meter. Okay, here you put the pressure meter. This is the level of the water. Water migrates over here. Now you measure the pressure. Here at particular temperature, these water molecules will come up in the vapor form, and again it tries to apply pressure on the water. That is the vapor pressure of this water. You note this in this pressure meter. Similarly, here solution is there. So here vapor pressure is less. Okay, here vapor pressure is less. Why? Because it is a solution. We have already discussed that vapor pressure of solution is always less than that of pure solvent. So here we have less pressure. Here less pressure, here more pressure applied. So solvent will migrate from this chamber to this chamber. We try to this type of migration of solvent from one chamber to another chamber is nothing but this osmosis. This process is known as osmosis. Understand this? Solvent migrate from lower concentration to higher concentration. If you connect this chamber, then instead of migration here it is 5 molar. So concentration difference is very less. Here if you apply the pressure meter, then here pressure is less. Okay, here pressure is less. Why? Because it is more constant. Vapor which is formed, it is very less. There is decrease in vapor pressure. So solvent migrate from this chamber to this chamber instead of this chamber. So water level is less in this. Okay, so that is known as osmosis. In the plant, in the roots, okay, roots absorb water from the soil. It is because of this osmosis. Water in the soil has less concentration, but in the root, in the plant cell, concentration is high. So water migrate from soil to the roots and plants. Okay, in our body also digestion will take place because of this. In our cell, concentration of fluid is high as compared to food. So that food will be digested in our animal cell. So that is osmosis. Now the process by which this osmosis is stopped, that pressure is known as osmotic pressure. Suppose the solvent migrate or water migrate from the other, so pressure will be increased. Now here you apply external pressure. The point at which this migration stop, or the pressure to apply to this chamber, so now water molecule will not flow. That pressure is known as osmotic pressure, and it is symbolized by pi. Osmotic pressure is symbolized by, and it is directly proportional to concentration. Okay, if you take out proportional constant, or is directly proportional to molarity. Now we discuss directly proportional to molarity. So pi is directly proportional to C, is equal to and CRT. If we take out proportionality constant, then CRT, that R is nothing but gas constant and T is nothing but temperature. The temperature in Kelvin, and C is the concentration. So C pi is equal to, concentration is nothing but it is mole per liter. Mole per liter means it is N by V. Okay, mole per liter, where V is the volume and N is the mole. Now we know that mole is equal to weight upon molecular weight. So pi is equal to, I am writing here, pi is equal to N by V RT. Pi V on this side, that it is nRT. Now N is equal to weight upon molecular weight. The molecular weight means molecular mass, RT. So if you want to find the molecular mass, then M is equal to pi W by WRT by pi. So by this method we can find the molecular mass of unknown solute added in the solution. Here it is NaCl. Instead of NaCl, if you add sugar, then its sugar molecular mass can be found. You add known amount of, W means what, known amount of weight of sugar, add to it. R is a gas constant, temperature known, volume of the solution, and pi is the vapor pressure. You pressure you measure it. Okay, or osmotic pressure. Then you can find what will be the molecular mass of unknown. So that is osmotic pressure. Second is isotonic. Isotonic solution means whose concentration is same. Suppose in both the chamber, if concentration is same, then osmotic pressure is same, then no migration of liquid will take place. So that both solution is known as isotonic. That two solution may be sugar or may be NaCl solution. If migration is not possible or osmotic pressure is same, then that solution is known as isotonic solution. Isotone means what? Pressure same, water pressure is. Here, if it is gas, then you have to use, instead of pi, you have to use P. Here it is water pressure, so we have used the pi. Hypertonic. Hypertonic means the solution whose vapor pressure is more than that of solvent. That solution is known as hypertonic. So here you can see hypertonic means this 5 molar acid, its concentration is more. So migration here it will take as compared to this. So this NaCl, 5 molar NaCl is hypertonic solution. Hypertonic solution, if you take the cell and you prepare NaCl, so more concentration. More concentration. From the cell, liquid migrate from this cell to the NaCl solution. If concentration is more, lower concentration to higher concentration. So that is known as hypertonic solution. Okay, NaCl. If the NaCl concentration is less, then water flow from cell to NaCl. So that is known as hypotonic. Again I revise. Suppose in the swimming pool, okay, if you mix the NaCl, salt water, and try to jump it and try to swim it. If concentration of swimming pool water is high or more, then water solvent from your body comes out in the swimming pool water. Okay, come out in the swimming pool water. If the concentration is high and if the concentration of fluid is low, then reverse will take place. Or you remember just liquid flow from lower concentration to higher concentration. Okay, liquid always flow from lower concentration to higher concentration. Again I take the example, if particular cell is placed in dilute solution, okay, or very dilute water, then water migrate from that particular liquid to the cell. And if that cell is kept in higher concentration, then cell water will migrate towards the outer solution. So bursting of cell will take. Okay, water from the cell comes out or water from the source goes into the cell is decided by the concentration. And to stop that, that is known as osmotic pressure. Okay, try to solve the illustration based upon this osmotic pressure. Okay, 2.11. Thank you.